Okay, in this video, we're going to talk about population growth. In population growth, we got two main factors and two main types of growth systems. We got the exponential growth, and we got logistic growth. The component of these two growths is one is variable is n, which is population size, and the next one is r, which is growth rate, and k, which mainly pertains to logistic growth, is the carrying capacity. The growth rate is determined by birth minus death, or population size, which is n, which gives us r. Our carrying capacity is the plateau, as it's like a plateau as where the population stops growing due to predation, competition, or limited resources. So a graph system to draw a visual of these is this would be the logistic, and this would be the K. See how it reaches a plateau? And we're going to start with exponential growth. So as you see here in exponential growth, I started off with n, which our n is our 15. We're going to start off with 15, let's say dogs or something, 15 dogs. And to complete this table, we have to find r. So r, like I said, is birth minus death over n, which is, we're going to say our birth is 6, and we're going to say our death is 2. So 6 minus 2 over 15 gives us 0.2, which gives us our r. So to continue this, to complete this table, we gotta use this equation right here, which is a change in population size over the change in time, which gives us the equation r times n. So we put in our 0.2, which is our r, times 15 gives us 3. We add that to the 15, gives us 18. Next one, we do 0.2 times 18, which gives us 3.6. Round it up to 4, we get 22. We do 0.2 minus 20, or multiplied by 22, equals 4.4, which gives us 26. And then we do 0.2 times 26, it gives us 5.2, which gives us 31. We're going to round it out, 31. So figure out the numbers for 10 and 15 and 30 years time. We're going to use a different equation, this, which is n equals n parentheses 1 plus r parentheses to the 10th to the our power is the time. So we're going to use 15. In this one, we do not change the n. We use our initial n, which is 15. So 15 parentheses 1 plus 0.2 to the 10th power, that gives us 93. And then 15, this right here, times 1.2 to the 15th gives us 231. And then 15 times 1.2 to the 30th power gives us 3,561. Our logistic growth table, it shows we use different types of equations for that. So this is our n column right here, which is our population size, the kn carry. This is the carrying capacity right here, and this is the change in time over the change in, or the change in population size over the change in time. This determines how many dogs, I guess, we're going to add on to our original. So to find this column, we use the k minus n over k, and we're going to say our k is 15 right here. Use 15, so we do 15 minus n, which is the original n, which is 4, and then you do that over 15, you get 0.73. Then you multiply 4 times 0.73, which gives us 2.92. And you keep going down the column. So 6.2, we do 15 minus 6.2 over 15, we get 0.54. And then we multiply that, 6.92, 0.54, gives us 3.74, so on and so forth. So as you keep going on, you'll see the carrying capacity gets smaller and smaller. That means it's about to reach this plateau where it can't, or the population doesn't exceed anymore. So, and that is population growth using exponential and logistic growth.